Hello, my name is Andy Hasselt, Connected Industry Consultant with Bosch Rexroth. Today I will present you our automatic production assistant, a collaborative robot called APAS. With over a decade of experience in developing cobots, we have come across a variety of different use cases which significantly influenced on how we approach the topics of cobots to collaboratively put robots into an environment to work hand in hand with our associates. Today, I will focus on two applications. On one hand, our APAS Mobile and our APAS Inline. We have developed a worldwide unique safety concept. What does that mean? You can see here in the picture on the right hand, a hand coming close to a gripper head or the robot arm. And we have about over 100 double channel capacitive sensors embedded in this skin that covers the entire arm of our robot. And with a range of about 50 millimeters, about 2 inches, the sensors will sense an operator or any object and will stop automatically without having physical contact. So think about you are working hand in hand with a robot, and yes, stopping it with your hand, with your forearm, may not hurt you. But what if you are moving around and suddenly this robot comes close to your head? Would you like to stop a metal object with your head? I do not. So this is why we implemented and developed this solution that the robot will stop without actual physical contact. In addition to that, it will not require a manual restart after a stop, after a trigger limit was reached. You do not have to acknowledge the fault. The robot will just pick up where it stopped and continue along its path. With these features, it will make it a lot easier to get your robots accepted not only by your associates in these environments, but also through certifying and governing bodies. We are, in terms of degrees of collaboration, are positioning ourselves in a D3 area, which means we have a permanent overlap in the working envelope, in the working space between the associate and the robot. So that means you can work next to each other. The robot performs tasks, you perform tasks, but also you can hand in hand, the robot can be handing you parts or vice versa. Another cool feature is our automatic speed adaption. In a close range, in close quarters, the robot will function like any other collaborative robot. Like I just described, you can work hand in hand with our APAS. In addition to that, if you do leave the area, and we can monitor this area, for example, through laser scanners, area laser scanners, pressure sensor mats, this robot can suddenly function at caged speeds. Like traditional robots enclosed in safety fences, we can go up to these respective speeds. Higher speeds means more throughput, faster execution, meeting your cycle times. Here's an area, as I just described. We are scanning an area around the robot. Is nobody present within that area? The robot functions at its normal speed. If somebody enters into our safety zone and comes into closer range of the robot will just slow down. It will not stop. And now you can perform tasks and functions respectively. If you do leave the area and it is clear again, the robot will go back to its faster speed. In addition, and in comparison to other robots on the market, we offer, since we are using industrial grade robots underneath our capacitive skin, a very, very high repeatability. So the precision in terms of grabbing parts and placing them and performing this task over and over again is significantly higher than we see with other cobots in the market. And in addition, the speed is an additional factor with far range area detection, for example, as I just described. We can reach speeds between 2.3 and 4 meters per second. So I would like to give you some ideas and some examples on how an APAS mobile can be used in an environment. You will see here the APAS mobile is a self-contained unit, comes with all the controls on board. All it needs is power. Depending on your grippers, maybe some air to function. It will come outfitted with a FANUC industrial robot arm, as well as our safety skin, a camera in the head, as well as a variety of different grippers are possible. What means mobile? Here you can see one of our associates moving the robot into its position at a workstation where it's supposed to perform a certain pick and place operation. The robot is on wheels. It gets positioned, clamped into position, and the program either be started if it had been already loaded to the robot, or through our very intuitive graphical programming interface, which is very simple and makes it fast to adapt to new environments, a new program can very quickly be loaded. Where does this come in quite handy and beneficial? Think about the variety of different tasks in your operation. With this mobile version, it allows you, for example, to move the robot from first shift to second shift to third shift to different applications. Why is this important? You're looking to drive for a very favorable return on investment with your robot, and by spreading out the task and applying it to multiple areas in your organization, it helps you to leverage the technology in the way it is intended to support your organization and support your associates. For the pick place operation, we can either include a stereo or mono cameras, infrared flashlights if desired and required, to identify parts and components as they're being brought over into a gripping area, into range of the robot, sense, identify, and detect the parts, grab them, and place them, either hand them off to a human or place them in another operation. Regarding end effectors, like any other robot, there are a variety of different possibilities available. You can choose from pneumatic applications or electrical grippers, or a combination of both, including a collision element, or we work with you and end effector providers to develop special solutions to fit your needs and realize your project effectively. Our assistant inline comes in two different models. We either have a FANUC with a 7 kilogram payload, or a KUKA KR10 with a 10 kilogram payload underneath our capacitive skin. Both robots will function and be programmed like a standard robot. And again, being an industrial robot allows you for the speed and repeatability that you need in your operation to function for many years to come. In terms of applications, I would like to just spur some thoughts on where these applications can be realized. What you can see here, an associate performing some picking operation, grabbing parts that are either further away, located from a conveyor belt from a kitting operation, or are much more difficult to grab, whereas simpler tasks, more repeatable tasks, the robot can function on its own and place those parts respectively on a conveyor. Here you see one of our KUKA robots functioning on its own in off shifts, for example, just performing tasks, load, unload, kitting operations, pick and place, packaging. Now, coming to logistics operations, we can pair our APAS solutions with our active shuttle, our autonomous guided vehicle, to place parts into containers and drive them to the point of use, or vice versa, return items from a manufacturing line to a central repacking location, and repackage into customer-specific applications. We will also show you a brief video just to spur more thoughts on where our APA solution could find more use cases in your organization. For any further questions, if you would like to discuss your projects with us, please feel free to contact me, andreas.hasselt@us.bosch.com. Thank you very much for your attention. Have a great day.
The clue of the automation is that it's an integrated camera. And the camera allows the robot to grip even parts which are not very well positioned. So you can keep your existing material flow components as these blisters which are not very perfect, and have a robust automation despite the fact that the parts are not very well positioned. The second thing is that it's completely fenceless, so interaction between humans and machinery is every time possible, and during machinery feeding the material flow can be continuously working by shuttling the next stack of material to the robot. This is the main advantage. This is very well suited for belated automation. Keep a lot of what you have, but improve it with our technology.